All right, so this is the final practice test review. Let's just start with the first question. So it says resolve the inequality. When you're doing this on the test, the question will say something like, solve the inequality, write the solution to the inequality in interval notation, and graph the inequality. So this is an absolute value inequality. If this is, I believe, from section 4. So when we have the absolute value inequality, we want to break up the absolute value into two different situations. That x minus 2 has a relationship with a positive 10, and the x minus 2 has a relationship with negative 10. In this case, the x minus 2 will be less than 10, and on the right side, it's going to be a greater than 10 because we multiplied that 10 by a negative, so we must flip the sign. So we get to, on the left side, add that 2 over, we get x is less than 12. Here we add the 2 over, x is greater than negative 8. We will go and graph that on a number line. So here's 12. It's an open circle. X is less than 12. And then we have negative 8 here. Open circle. X is greater than negative 8. Because those two are going towards each other, they are going to crash and create the interval in between. So there's our graph, and it is showing that x is in between negative 8 and 12. So interval notation will go from negative 8 to 12 with parentheses not equal to. This next question says, a quarterback throws a football from an initial height of 5 feet. The height of the ball is represented by the equation h of j equals negative 15j squared plus 75t, that should be a j, that's a typo, plus 5. So we are trying to find the maximum height the quarterback throws the ball. So what's happening here is the quarterback is throwing the ball in a quadratic path. So the maximum height here of the ball is going to actually be the vertex. So if we're going to find the vertex of this equation, we need to find the x value and the y value of the vertex. The x value of the vertex is negative b over 2a. So if I use the equation, we get negative 75 over 2 times negative 15. And if we do that math, negative 75 divided by negative 30 is 2.5. So that is the x value of our vertex. Then we need to find the y value of our vertex, and that is just done by plugging 2.5 into the function. So we've got negative 15, negative 15 times 2.5 squared plus 75 times 2.5 plus 5, which I would use a calculator for that. And assuming my calculator didn't make any mistakes, we get 98.75 as my y value. So our vertex is 2.5, 98.75. Now the most important part of this problem is interpreting what the vertex actually means. So in this case, there is a maximum height at the y value. So there's a maximum height at 98.75 feet when the ball is in the air for 2.5 seconds. So that is what that vertex means. The y value is the actual maximum or minimum value, and the x value, or in this case it was a j value, but I still think of it as the x value, that is the location of our maximum. In this case, how long it took to get to that maximum value. Okay, question 3. This is a very important question on here. In fact, on the test, I will let you know right now that we will give you the same problem for both complete the square and the quadratic formula, and you must show every single step in order to get these problems right. Okay, anything skipped or not shown will be a deduction on the problem. So let's look at A. In this case, we don't actually have the same problem, but let's just do each one of these so we know what all the steps are. So if I have x squared plus 18x plus 54 equals 0, and I need to solve this using completing the square, the first thing I need to do is make sure that the value in front of x squared is a 1. If it is not a 1, I'm going to divide every term in my equation by that number. In this case, it is a 1, so I'm okay. I can proceed without having to do that. But be aware that that is an important step. So then the next thing I'm going to do is I'm going to subtract the 54 over. Okay, what that does is it makes it so that I can add something to that left side so that my left side can become a perfect square. So that means I need to complete the square. Complete the square means that we just take the b term, that 18, and we divide that by 2, that is 9. And then we take the 9 and we square it, that's 81. So the value that I add to both sides of my equation would be 81. Now that I've added 81 to both sides, I am going to factor the left side into its perfect square. And then I'm going to go negative 54 plus 81, which is 27. Now, completing the square has allowed me to solve the remaining equation using the even root property. So I'm going to square root both sides of the equation. Okay, and then I get x plus 9 equals plus or minus the square root of 27, which is 9 times 3, and the square root of 9 is 3. So that's 3 square roots of 3. Then the last thing I need to do to solve for x is just subtract the 9 over. I like to keep that subtraction on the left side of my radical because that is the same setup as it would be in the quadratic formula. So then there is our simplified answer using complete the square. It is important on these to make sure you simplify all the way so that you get all the points for the problem. Alright, so for the second part of this problem, we have to solve the same problem using the quadratic formula. In this case, the problem's a little different, but they will be the same. Let's see. So we have the quadratic formula. So we need to take this 4x squared minus 3x plus 8 equals 0. And using the quadratic formula, which is the formula x equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So we're going to make sure we know what a, b, and c are. A is the value on x squared. B is the constant on the x, including its sign. And c is the individual coefficient. Individual constant, sorry. So we put those into the formula, so we have x equals negative b, so that's negative 3, plus and minus the square root of b squared, so that's negative 3 squared minus 4 times a times c. All of that over 2 times a. Okay, so then we're going to start simplifying that answer here. So we've got x equals negative 3 is 3 plus or minus the square root of negative 3 squared is 9. And then we have 4 times 4 times 8. So 4 times 4 is 16 times 8 would be 128. And all of that over 8. Okay, so then we go and simplify inside that square root a little bit more. So 9 minus 128 is negative 119 all over 8. And we can't simplify the factors of 119 into this or out of this, but we can take out a negative. So the square root of a negative is I. And I believe 119 is prime. Actually, it's not prime. It has 7 times 17, but both those numbers are prime. They're not square roots. So we can't really do anything with the square root of 119. So I'm just going to take that 8 and divide it into each term. I like to do that because if something does reduce, you can reduce it individually. And I also like to break up the answer because you like to have the real part and the imaginary part separated on complex numbers. So this would be our final answer. Question 4 tells us to graph the quadratic equation pretty much by finding the vertex and the intercepts. We don't need to worry about this axis of symmetry here. So what we're going to do is we're going to start out by first finding the vertex. And we've already done that. It's the exact same process. So we have the x value of the vertex is just going negative b over 2a. So we're just going to go negative, our b is 8, over 2, and our a is 1. So it's negative 8 over 2, which is negative 4. Now we have the y value of our vertex. The y value of our vertex is found by just plugging the x value of the vertex into the function. So we have negative 4 squared plus 8 times negative 4 minus 20. Alright, and so that equals negative 26. So our vertex, the point, is negative 4, negative 26. Now that is going to be off of our graph here. On your test, we have made sure that your points will be on the graph, so don't worry about that too much. Okay, the next thing that we need to do after we find the vertex is find the x-intercepts. And to find the x-intercepts, we plug 0 in for y or f of x. So I'm going to plug that in. I'm going to set my whole equation equal to 0 because the whole equation equals f of x. and I'm going to factor. So the factors of 20 that give us 8 are positive 10 and negative 2. So my x-intercepts are x equals negative 10 and 2. I'm not sure what happened to my screen on here. Hopefully it still looks okay. But here are our x-intercepts. The last thing we need to do is take our function and find the y-intercepts. So I have x squared plus 8x minus 20 equals y. And in order to find the y-intercepts, we're going to just put 0 in for our x's. So we've got negative 20 equals y is our y-intercept. Okay, we're just going to go and graph that. And because there's such big values, we'll just get estimates here. So let's see, there's 2, that's 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We're going to need that one. 21, 22, 23, 24, 25, 26. Okay, so we're going to just plot these points on here and use a different color on my graph. Alright, we have the vertex here, which is negative 4, negative 26. We have the y-intercept, which is negative 20. And then we have the x-intercepts, which are negative 10 and 2. And I'm going to just connect those points. We've got the left side, and then the right side should look just like the left side. And there is our quadratic function. When the graph does ask about the axis of symmetry, it's just saying the graph is symmetric. Where is it symmetric about? And that's just at that x equals negative 4. It flips over itself. But you don't need to worry too much about that. Okay, question 5 says to solve the inequality. Remember, when you're solving an inequality, the solution is always the interval notation and the graph. So we've got x plus 7 over x minus 1 is greater than 0. So we have a rational inequality that we need to solve. First thing you need to do if you have a rational inequality is, if either the numerator or the denominator can be factored, make sure you factor it. In this case, it can't be factored. So we move on to finding what I call the critical values. So the critical values from the denominator would be when the denominator equals 0. And the denominator equals 0 when x equals 1. However, x cannot equal that value because you can't have 0 in the denominator. So the critical value from the denominator will go on the number line as an open circle. So if we put that on our number line here, we have when x equals 1, that is going to go on our number line open. Okay, now after we find the critical values for the denominator, we're going to find the critical values for the numerator. In this case, our numerator is x plus 7. When does x plus 7 equal 0? That is at negative 7. So we're going to plot negative 7 here on our number line. And here we need to decide, am I putting this circle on the number line open or closed? In this case, I'm going to put it on the number line open because I have an inequality sign that is greater than, and it does not say equal to. It is just greater than. If you have greater than or less than, we will put that on our number line as an open circle. Okay, after we test or find our critical values, we are now going to test the intervals. So I have my equation, or expression, I guess, would be x plus 7x over x minus 1. And I want to see if that expression is positive or negative for each interval. So I'm going to start to the left of -7 is my first interval. I'm going to pick an arbitrary number. You can pick something different than me and it doesn't matter. I like to pick nice round numbers, so I'm going to pick -10. And I'm going to plug -10 into my equation. So -10 plus 7 is a negative. -10 minus 1 is a negative. A negative divided by a negative is a positive. Then I'm going to pick something in the interval between -7 and 1. 0 is in that interval, so I'm going to pick it. I always pick 0 if it's in my interval, because it's super easy to work with. 0 plus 7 is positive. 0 minus 1 is negative. A positive divided by a negative is a negative. Okay, and then I'm going to pick something to the right of 1. Let's just do 10. 10 plus 7 is positive 17. I don't care that it's the 17 though. The positive is what matters to me. 10 minus 1 is positive. A positive divided by a positive is a positive. Okay, now that we have our sign chart, or where we tested the intervals, we need to just decide which intervals make my inequality true. So my inequality says greater than 0. Positive numbers are the numbers that are greater than 0. So that means the positive intervals are the intervals that work. So I'm just going to go to the positive intervals. Now we're not worried about negative x values. We're worried about essentially what the y value was, or the expression value was, when the x was either positive or negative. So in this case, it's okay to have an interval that is negative numbers, even though we are less than 0, because it's not the x values I'm concerned with. So my first interval that works is -infinity to -7, and my second interval would be 1 to infinity. And that is the solution of my interval notation, and the graph also needs to be included on these problems. Okay, I'm going to do question 6 and question 7 kind of at the same time because they are very similar questions. So let's take a look at number 6 first. It's just asking us to take the logarithmic equation and rewrite it into exponential form. We're not even going to worry about simplifying these. We're just going to take them and rewrite them. So here I have log 81 x equals 1/3. That looks like a 1/2. That's a 1/3. Okay, so to rewrite a logarithmic expression as an exponential expression, I start with my base and I hook around to the other side. And that's going to be my exponent part. So 81 to the 1/3. And then those squeeze together and it pushes the x out to the other side. So here is my logarithmic expression rewritten as an exponent equation. So I now have the exponential equation 6 to the 7th power equals x. And I want to rewrite that as a logarithm expression. It's the same idea. We start with our base, and I'm going to hook my base around to the other side. Log base 6 of x, so those squeeze together, and that pushes the exponent to the other side. And that is our exponential equation written as a logarithmic equation. Okay, question 8. Let's see. We are just rewriting these expressions or simplify them essentially without using a calculator. So I'm going to use my rules of logarithms. So my first rule of logarithm here, let's say I have log base 11 of 121. Now, I can rewrite that 121 as 11 squared. And then whenever you have a logarithm with a base and then the same expression with a base to an exponent, those cancel each other out. So log base 11, 11 squared, the 11s and the logs cancel out and we are just left with 2. All right, so that's our rule of logarithm. Whenever you have log base a to the nth power, that equals n. It simplifies that much. Okay, and then 8b, this rule is even easier. If you think about anything to the 0 power, that is always equal to 1. So if I have log base anything of 1, if you think of that as an exponential expression, it should just be 0 because 4 to the 0 power is 1. So log base anything with a 1 is always going to be 0. And then my last rule here, 8c, if I have log base 3 of 3, well, we know 3 to the first power equals 3. Okay, those are my rules of logarithms. The rules of logarithms are found in section 38, so you can go over those if you need to. Okay, so quite possibly the easiest question on this test review, and if it were on the test, or if it is on the test, it would be a multiple choice question for sure, is find the center and the radius of the equation here. So remember that a circle's equation is x minus h squared plus y minus k squared equals my radius squared. So I need to find the center, and that would just be the opposite sign of what's inside the parentheses. So if I have x minus 2, what makes x minus 2 equal to 0? That's a negative 2. And what makes y minus 9 equal to 0? That's a positive 9. So there's my center, negative 2, 9. Now my radius is found by the part that it equals. So I have equals 36. So in this case, what squared is 36? That would be 6. And there's my center and my radius. Okay, question 10 says find the slope between the 2 points. So we're just going to use the slope formula. So we've got 5, 2, 7, 3. And we have our slope formula is y2 minus y1 over x2 minus x1. So we plug those points directly in. So we have 3 minus 2 over 7 minus 5, which is 1/2. Now we'll just reduce that if we need to. In this case, we don't. So that is our slope. All right, on question 12, we're going to write the equation of the line and slope intercept form for the lines passing through those points. So the first thing that I want to do is when I'm writing the equation of the line, is we need to figure out what the slope is. In this case, our slope we're going to do using what we did on question 10. Also, I did skip question 11. We'll loop back to those type of problems at the very end. So we have 15 minus 13 over negative 11 minus negative 8. So that would be 2 over negative 3. So there's our slope, negative 2/3. Okay. Now, once we find our slope, we need to put all of the information we have into y minus y1 equals m times x minus x1. y1 or x1, y1 is a point, and it can be either one of the points. So I'm just going to use the first one, negative 8, 13. And I'm going to put them directly into that equation. So y minus our y point, which is 13, is equal to our slope, which is negative 2/3, times x minus the x point. Now that's our equation of the line in point-slope form. The last thing that we need to do is put it into slope-intercept form. So the last step when we're writing the equation of the line is solve for y. Okay. And when we're solving for y, it's pretty simple here. We are just going to, distribute the negative 2/3 through. So we've got negative 2/3 x, and then negative 2/3 plus 8 would be negative 16/3. Okay, then I just need to add 13 over. That's probably the hardest part of the problem, is adding a fraction. So negative 16/3 plus 13/3. Nope, not 13/3, just 13 will be the answer. Now we just need to actually combine the constants. So I'm going to find a common denominator there. So that's negative 16/3 plus 39/3 will be 23/3. So 23/3, and then the rest of my equation, like that. Sorry, that's so sloppy. I can't find my pencil to write on this, so I'm using my finger. But we'll make do with what we've got. Okay, so there's our answer. And that is it. Now, if they did ask you to graph that, you would want to graph. In fact, the next question on 13, we'll graph it along with finding the equation of the line. Okay, question 13 is very similar to question 12. There will be one or the other on the test. I don't think we would have enough room for both, but I want you to be able to see both because they are both very important concepts for college algebra. So we want to write the equation of the line passing through the point negative 3, 4, and parallel to the line y equals 2x plus 5, and then we're going to graph that line. So the first thing we need to do is we need to find the slope. Well, there's a couple ways to find the slope. If we have 2 points, then we just put it into the slope formula. In this case, we have a parallel line. So we know that the parallel slope is the value that is on x. So that is 2. And parallel lines have the same slope. So that would also be our line slope. So we have our slope is going to be 2. If we had a line perpendicular, it would be the negative reciprocal slope, but in this case it's just parallel. Then after we have the slope and we have a point, we are going to put the information into our point slope formula of the line. So we have y minus the y point equals our slope times x minus our x point. So minus a negative 3 is plus 3. Okay. The third thing to do is solve for y. So I have y minus 4 equals 2x plus 6. And then I add the 4 over, I get y equals 2x plus 10. So there is the equation of our line. Now we're not quite done with this problem because they do tell us to graph. Okay. So we're going to graph this line by starting with our y-intercept. Our y-intercept is at 10. So I'm just going to plot a point on the y-intercept. And then we're going to apply our slope. Our slope is 2, which means 2 over 1. That means we will rise 2, run 1. Okay, so we are going to rise 2, run 1. And if you want to do that again, you would rise 2, run 1. So that's rise 2, run 1. Then you only need 2 points to make a line, but if you want a couple more just to make it more accurate, that's fine. There is graphing the equation of our line. Okay, let's solve the system of equations here. So if we have a system of equations, you can solve that using the graphing method, which I don't recommend. You can solve it using substitution or elimination. I'm actually going to use elimination. I think that's the easiest method here. So we have 5x plus 2y equals 21 and 2x minus 3y equals 16. Okay, so the elimination method just tells us we want to eliminate one of our variables so that we can solve using just a basic linear equation. So I'm going to eliminate my y's because they're opposite signs. And I think it's easier to eliminate when they're opposite signs. So to do that, we need the greatest or the least common multiple between 2 and 3, which would be 6. So I'm going to multiply the top equation by 3 and the bottom equation by 2. So those equations become 15x plus 6y equals 63 and 4x minus 6y equals 32. Okay. Now that I have that system of equations, the y's are the same number but opposite sign, I can add the two equations together. So that would be 19x, the y's cancel, and we are left with 19x equals 95. There we go. Okay, so we are just going to solve for x now by dividing both sides by 19, and we get that x equals 5. Now, the solution to a system of equations is not just one x value. It's actually the x and the y value that make both equations true. So we have our x equals 5. We need to figure out what the corresponding y value is. Okay, so we can plug that y value into any equation. So I think let's just use that top equation. If we know that we have 5x plus 2y equals 21, and we know our x value, we can figure out what our y value is. So we have 25 plus 2y equals 21. I'm going to subtract the 25 over. So that's 21 minus 25 is negative 4. And divide both sides by 2, we get y equals negative 2. So that means the solution to this system of equations is the point when x is 5 and y is negative 2. And that is it. That's all you need to do to solve a system of equations. Okay, question 15 says to factor. Now, you're going to be very happy you're watching this video because when the TA wrote this problem, I don't think they realized what the point for A was. So I'm going to rewrite question A. I'm going to write that as x cubed. I'm going to keep the minus 7x squared. Let's go minus a 4x and then plus 28. So I'm rewriting that to factor it so it aligns with the purpose of this problem, and it will align with what you'll see on the test. So we have x cubed minus 7x squared minus 4x plus 28. I need to factor this by grouping because there are 4 terms. So I am going to group the first 2 terms together, and then I am going to group the second 2 terms together. And I am going to factor those each individually. So the first group has a common factor of x squared, so I'm going to factor x squared out. The second group has a common factor of 4, but I also want to include that negative 4 here. So that's x minus 7 there. Okay, now, so we want to, from here, factor the common binomial factor out. So in this case, both groups have an x minus 7 as a factor. So I'm going to factor that x minus 7 out. And there we go. Then I look to see, can any of my factors be factored further? In this case, the answer is yes. So I want to factor this x plus 2, x minus 2. And then we have our entire polynomial factored into its individual factors. Now on B, here, it's a little bit harder. So we're going to start this one by looking for a common multiple through the entire problem. In this case, between 20, 34, and 40, there is a common factor of 2. So I will want to make sure I factor that common factor out. So 34 divided by 2 is 17x minus 20. So I pull that common factor out. All right, now we need to factor the remaining trinomial. So I'm going to take that 10 and I'm going to multiply the 20. So I've got 2x squared plus 17x minus 200. Okay, we need to find 2 things that multiply to get to negative 200 and add to get to 17. So if you want to pause this video and try and think of them yourself, you can. Let's see if we can get them. Luckily, they're opposite signs, so that kind of helps us a little bit. Let's see. If we have 8 quarters, that's $2. So that would be 8 and 25. So one of them has to be positive and one's negative. And I think, let's see, it's a positive 17, so the 25 is the one that has to be negative. So when we go to factor this, we have x plus 25, x minus 8. Now we're not done with factoring though, because we did multiply by 10, we have to go back and balance that out. Reduce those fractions. So this first one, divide the top and bottom by 5. And the second one, we're going to divide the top and bottom by 2. Okay, and then because we are factoring, we need to bring those denominators onto their x. So we have 2x plus 5, 5x minus 4. That 2 that we factored out at the beginning of the problem is still part of the factoring, so we need to kind of carry it with us as we go. All right, so there is our factoring, a very, very important skill for college algebra. So you need to make sure that you have factoring down before you take college algebra. Okay, so for question 16, well, we're getting there. This is a long test review because there's a lot from the semester that we need to go over. So we need to state the restrictions and then solve for x. Stating the restrictions is going to be part of your problem, so you need to make sure that you do that. So the very first thing we want to do when we're solving this problem is factor any denominators that can be factored. That's going to actually make your problem easier if you can factor. So we've got that x squared minus 16 factors into x plus 4x minus 4. And then, there we go. That was the only thing that could be factored. Now we have to find the LCD, which in this case will be x plus 4x minus 4. So we're going to multiply every part of our equation by our LCD. So there we go. And we're going to cancel anything that can be canceled. So we are left with here 7. We'll cancel the x plus 4s. And that gives us 3 times x minus 4. Then we'll cancel the x minus 4s. And then we are left with 1 times x plus 4. Now, I forgot something, and I said it was an important part of the problem. I did forget to state the restrictions, so let me just write that down. The restrictions do come from the denominators, so we just have the x cannot be 4 or negative 4. Because you can't have a negative in your denominator. Okay, sorry about that. Now we're going to come back to this linear equation that we've created. That is the exact same equation as my rational one without the fractions. So I'm going to solve this by distributing this. We have a positive 3 we need to distribute through. If it is a minus, make sure you distribute the negative through. Then we've got x plus 4. And let's see. So that's 3x minus 5 equals x plus 4. Which gives us 2x equals 9. So x equals 9 halves. 9 halves is not one of the restrictions, so it is our solution. And that's all you need to do. Just make sure you have the restrictions on there and the solution. Okay, question 17. We are just going to simplify this expression using our rules of exponents. So, hopefully you remember those. The first thing we want to do is simplify inside the parentheses. So I'm going to simplify 81 divided by 27, which would be 3. And then I have x to the 5th over x to the 12th. So the 5 is going to come down and subtract from the 12. 12 minus 5 would be 7. And then y to the 6, negative 6 over y to the 8. Let's bring that 6 down. And then combine those terms. So we've got x to the 7th, y to the 14th squared. So that's the first thing, is we just simplify inside the parentheses. That is going to make squaring everything so much easier. So you don't have to go 81 squared. What is that? That's a really big number. So it'd be easier just to simplify first. Then, once we do simplify that, we're just going to square everything in there. So 3 squared is 9. X to the 7th squared, we multiply the exponents. 7 times 2 is 14. And y to the 14th squared, so 14 times 2 is 28. And that's it. There are no repeated variables, so every variable is combined. There are no more parentheses. There are no negative exponents, so we have this simplified all the way. Okay, question, I believe 18, it got cut off on the picture there, tells us to do long division. So I'm going to set up my long division, 3x plus 1, and then we have 3x to the fourth minus 5x cubed plus 10x squared. I'm just double checking that there's no skipped variables, and there's not, so there we go. If there is a skipped variable, make sure you write 0 as a placeholder. Okay. Let's start the division process. So we're going to go and we're going to divide that 3x into 3x to the fourth, which is x cubed. That's our division. Then we are going to multiply. X cubed times 3x is 3x to the fourth, which I need to erase this so I can write it. So we have 3x to the fourth, and x cubed times 1 is x cubed. So that is our multiplication. Now we will subtract. So that's a positive, it becomes negative. This one's a positive, becomes negative. And we have 3x to the fourth minus 3x to the fourth is 0, which is what we want. And negative 5x cubed minus x cubed is negative 6x cubed. Then we will bring down each of the terms. You don't have to bring them all down. I like to, though, so it's a preference. All right, then we're just going to repeat that process. So we've got 3x goes into negative 6x cubed, negative 2x squared times. Then we will multiply, so that's negative 6x squared, cubed, and then negative 2x squared. Okay, we will go through and change each thing's sign. That becomes a 0, and that's 12x squared plus 19x minus 9. Okay, so let's do the process over again. So if you get the process, these problems are super repetitive. So we're going to do the division again. 3x goes into 12x squared, 4x. Then we multiply, that's 12x squared, and then positive 4x. We'll change each thing's sign. And we get 19x minus 4x is 5x minus 9. Sorry, not 5x, it's 15x. There we go. Okay, then we're going to go and do the last one here. 3 goes into 15 5 times. And then 5 times 3 is 15. 5 times 1 is 5. So I'm going to subtract each thing, change each thing's sign. And we've got 15x minus 15x is 0. And negative 9 minus 5 is negative 14. Okay, so what we have to do is just write our final answer. So I'm going to write that down. We have our quotient, which is x cubed minus 2x squared. Sorry, formatting problem here. Plus 4x plus 5. And then we have a remainder of negative 14. So we're just going to go negative 14 over our divisor, 3x plus 1. Okay. So I know these are long problems, But there's not a whole lot you have to remember because you just do the same process over and over and over and over again in this case. All right, we're on the home stretch of this test review. So let's look at question 19. Okay, so for this question, we need to solve the equation for x. We're going to use u substitution. Now, I'm going to always let u equal that middle variable, so u is x squared. And then we square our u, we get x to the 4th. Okay, so then we're going to substitute that in. So we've got u squared minus 13u plus 36 equals 0. And then let's factor. So the factors of 36 that give us negative 13 are not u. Sorry, that should be a u. Just force of habit there. Okay, so that's a u minus 4. So we get our solutions for u are that u is 9 and 4. Now we're going to replace that x squared back in for u. So x squared equals 9. We solve that by square rooting both sides and getting plus or minus 3. And then on the other side, we've got x squared equals 4. We square root both sides, and whenever we square root both sides, don't forget the plus or minus. So there's our solution. X is plus or minus 3, plus or minus 2. And we get 4 answers, which is good because we've got x to the 4th. Okay, question 20. I want to talk about this just a little bit. So this one is a multiple choice one where you just identify what is the shape and what does its graph look like. You don't have to graph any conic sections on this test. You just have to match the graph. So in this case, our first one would be a circle. And you should know what the general shape of a circle looks like. So you're just going to match which one of the graphs is the circle. In this case, the circle looks like, this circle will look something like that. Okay, so there's our circle. The next one here, y minus 4 equals x plus 8 squared. So only one group is being squared here, so that means this is a parabola. Some teachers will say parabola. I like parabola. This parabola is x dominant, so we're going to something like that. That's not actually the right graph exactly, but you just need to know what a parabola looks like, which you should because most of this unit we looked at solving quadratic equations and parabolas. So parabola is a quadratic equation. Okay, on C, I have two groups. They're both squared. One is positive, one is negative. So that's a hyperbola. So a hyperbola, in this case, this hyperbola is going up and down. So it's almost like you have two parabolas. A little different than that, but you might have some asymptotes that you're going to approach, but there's your hyperbola. And the last one that we have here is, oh goodness, there is a typo. Let's fix that typo. One of these has to be negative. So we're just going to say this one's a plus. And then that will be an ellipse. So definitely a typo, needs to be fixed. On D, an ellipse. This ellipse is longer horizontally, but it will be below the x-axis there. So there's my ellipse in that case. So you just need to be able to know what each shape is and how to match them. Okay. Okay, 21, the last question on here. This is going to involve section 37 and 38. And it's just going to have you graph a logarithmic equation and an exponential equation together. The reason we do these together is it's actually easier together. So we're going to first start with a point the function goes through. In this case, all exponential functions go through the point 0, 1. The other point that all exponential functions go through is 1, whatever its base is. In this case, its base is 9. Okay. The domain of an exponential function is always negative infinity to infinity, and its range is 0 to infinity. So the domain are the x values and the range are the y values. And then all exponential functions have that horizontal asymptote at, not x equals, sorry, y equals 0. So that is our exponential function. If we take a look at that and graph it, so 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to go through the point 0, 1 and 1, 9. And then come down and approach. So there we go. I'm actually going to color that one in pink. So we know that's not supposed to go below the x-axis, so this is harder than I thought with my finger. There we go. So there's our exponential graph. Then we have our logarithms. Now logarithms, that sounds super intimidating, but it's very easy actually. Logarithm and exponentials are inverses of each other, so their x and y points just switch. So in this case, instead of going through the point 0, 1, it's going to go through the point 1, 0. Instead of going through 1, 9, it's going to go through the point 9, 1. And then the domain, which is the x values, become the range, which is the y values. So that's going to go through negative infinity, infinity. And then our range is going to go through 0, infinity. Then we have our asymptote, which changes from y to x equals 0. So if we look at that, on the graph, 1, 2, 3, 4, 5, 6, 7, 8, 9, instead of going through the point 0, 1, it's going to go through the point 1, 0. And then it's going to go through the point 9, 1. So those are essentially the same graph reflected. Okay, that is the test review for the final test. If you have any questions, feel free to text me. My phone number is on the syllabus for emergencies. And if you are taking the test early, please make sure you have contacted me about that. If you're not, make sure you sign up to take the final in the testing center, part 1 in the testing center, and part 2 will be actually in class with me. All right, good luck studying.